Welcome back. In this class, we will see some other implementations using switch logic. Now you can observe this is an AND gate implementation using switch logic. If you observe that, what is the AND gate when the two inputs are 1, then it is going to be produce an output. Then for the remaining all combination, it should produce an output as 0. That means if one of the input of an AND gate is 0, then automatically the output is 0. You can observe if you want. Is it clear? When the two inputs are 1, then only it will produce an output 1. Then shall we cross check this? Okay, now let us consider A is 0, B is 0. Now let us assume A is 0, B is 0. Now you can observe what is happening here. If B is 0, then this transistor won't be turns on, then this transistor will be turns on. Because B is 0, B complement becomes 1. Therefore, what is the input here? 0 is the input, therefore it will pass to the output as 0. Is it clear? Now similarly, let us consider A is 0, now B is 1. If you observe that B is 1, therefore this transistor will be turns on, this transistor will be turns off. Now at this condition, what is A? 0. Therefore, the 0 is going to be passed to the output. Is it clear? Now if you observe, A is 1 now, B is 0. If you observe that B is 0, therefore this transistor will be turns on, this transistor will be turns off. Then what is an output here? Absolutely, 0 is an output. Now you can observe the final combination. A is 1 and B is 1. Since B is 1, this will be in off condition, this will be in on condition. Therefore, what is an output? 1 is an output. But here the very important thing you have to remember is, okay, since it is an NMOS transistor, it won't pass strong 1. Is it clear? Therefore, the output is not 1, the output is VDD minus the threshold voltage. Is it clear? Therefore, we are once again telling that there is no full swing in this pass transistor logic. We do not have any full swing. Therefore, what should you have to do? You have to replace with a transmission gate. Okay, this is one transmission gate, this is another transmission gate, and these two are combinedly joining to get your output F, and this is your input A, and this is your input 0. And the main thing is how to give this control signals. That is the main thing. You can observe this in this NMOS, B is connected, therefore here you have to connect B and it becomes what? Automatically B complement. Then here in this NMOS you have to connect what? B complement, and automatically you have to connect B here. Therefore you have to join these two and commonly you can call it as B. I hope that are clear. In this fashion you have to design with the help of pass transistor logic, and in this fashion you have to design with the help of transmission gate logic. Is it clear? And if you want some other circuits, you can observe from here onwards. Yeah, you can observe these are the some of the implementations using pass transistor logic. It is the dual implementation type. You can observe this is an AND gate, this is a NAND gate, this is an OR gate, and this is a NOR gate, and this is an XOR gate, and this is an XNOR gate. Is it understood? This is a very simple implementation. If you observe these circuits, you can verify your functional table of respective logic. Is it understood? Once again I am telling that, are you clear how to replace pass transistor logic with the transmission gate logic? And I would like to talk a very important thing here is, okay, while designing your circuitry with the help of pass transistor logic, okay, you have to keep in mind a very important point. Okay, that point, the output of one pass transistor logic should not be act as a control signal to another pass transistor logic. That means, yeah, this type of connection should not be happen in PTL. That means let us consider if B is 1, A is 1, then what is the value of X? 1 generally, but don't forget the value of X is not 1, that is the VDD minus VDN is the value of X. Then if this is acting as a control signal, let us consider that much, okay, voltage is not there after X. You can observe that even though you are giving a supply to this transistor, it won't turns on. It will be in off condition because there is no sufficient voltage. There is no sufficient voltage. That means there is no that much voltage to turn on this transistor. I hope that are clear. Therefore, once again I am telling that the output of one PTL should not act as, okay, control signal to the other transistor. It can be happen. It can be happen. Is it understood, all of you? That means series connection is possible. Is it understood? But this type of connection is, okay, I'm not saying that it is not possible. It is possible, but you should not implement in this fashion. I hope that are clear. Okay, yeah, that is the thing. If you want one more implementation, up to now we have seen the combination circuit implementation. If you want, I will show one sequential circuit implementation, that is a D-latch implementation. Now you can observe that very carefully. Yeah, now I am going to implement D-latch. If you observe, first of all, we know very well clock, we are having a D, and we can talk about an output Q. If clock is, let us consider it is high level D-latch. If let us consider if it is 0, irrespective of input, it should act as a memory. I hope that are clear. Now if it is 1, then if D is 0, the output should be 0. If clock is activated, if D is 1, then the output should be 1. Is it clear? Now based on this, let us see here. Okay, let us consider you are having one PTL here, and I am using a buffer here, that means back to back NOT gates, and I am connecting the same thing here. You can observe I am connecting here. Now let us consider it is a D, and it is your Q. Now let us consider it is a clock and it is a complement of clock. Now you can observe this one. What is this one? This one you can observe. What is this one? Memory. Is it clear? Now you can observe if clock is 0, then this transistor will be turns on. Then whatever the output you are having, that will be, I will use some other color, then it is very better to you to understand. If clock is 0, then this will be turns on, then whatever the output Q, that will be come here, and since it is a buffer, that will be stay like this itself. Is it understood? Now you can observe once again. Okay, if clock is 1, what will happen? You can observe if clock is 1. Okay, if D is 0, let us know clock is 1 means it won't be turns on. Is it clear? It will be turns on. If D is 0, then the output is what? 0. I hope that are you clear. And if clock is activated, if D is 1, then you can observe what is an output. You can observe very clearly. If D is 1, the output is 1. I hope that are you clear. In this fashion you have to design. Is it clear? If you want to replace with what we'll call transmission gate logic, I will show one more time. This is with the help of pass transistor. This will be D, this will be clock, it is clock complement, and it is Q. Now how to replace? Yeah, absolutely, I said already, you have to replace at each position with the transmission gate. Let us consider this is one transmission gate and back to back NOT gates, and you require here one more transmission gate. and it is connected like this, then it may be D and it is Q. Now how to give a clock, that is an important. For this NMOS CLK is given, therefore here it should be CLK, here it should be CLK complement. For this NMOS CLK complement is given, therefore it should be CLK complement and it should be CLK. I hope that are clear. That's it guys. This is the about how to implement any circuit using switch logic. Is it clear? And what is the limitation we have seen in PTL? We do not have any full swing. Okay, and the output of one PTL should not act as control signal. I hope that are clear. This won't be happen. Is it okay? Thank you very much. If you are having any queries, please comment. Have a nice day.